All right. Well, again, thank you for joining us today. My name is Gene Hatch. I'm the meteorologist here at the National Weather Service in Springfield, and I'm also the station's climatologist. So this is something that I kind of look at, almost daily when we start talking about climatology and normals and things like that. And that's what we'll be covering today, taking a look at, some of the things we normally expect to see in the summer across the Ozarks, and also look at the changes we're seeing in the new 30-year normals and what the 30-year normals period really is. Let me get on the right screen here. Got to click the right thing. There we go. Some of the topics we'll be looking at today, again, is that traditional summer climatology, the new 30-year normals. We'll look at the longer range forecast from the Climate Prediction Center and some of the things that go into that, and ultimately what the expectation or the outlook is for the summer as we go through this year. First off, what is summer? Well, depending on what you're looking at, there's two types of summer periods, really. There's a meteorological summer, which generally is just broken down by month, starting on June 1st and going to August 31st. But there's also astronomical summer. As you've all heard, the first day of summer generally falls between June 20th and 22nd and ends sometime, September 20th to 22nd. Of course, this year, astronomical summer in the Northern Hemisphere actually begins Sunday, June 20th, and will end Wednesday, September 22nd. However, when we start talking about a lot of these, what we're going to talk about today, we're going to be referencing meteorological summer. So we're going to be looking at that June through August timeframe. So far, if we look at that summer beginning on June 1st, we're not that far into our summer yet. But so far, for the first 2 weeks of meteorological summer, on the left-hand side there, you can see a plot of temperatures so far, the departure from normal. So we have been slightly warmer than normal for the beginning of summer so far, beginning of June, and slightly on the wetter side as well when we start looking at the accumulated precipitation. Now, will this continue? We'll take a look at that and see, but just wanted to kind of give you an idea of what we've seen so far this summer. All right. So we all know that summer is in the Northern Hemisphere is kind of the hottest part of the year. For the United States, generally, the hottest days of the year can be anywhere from June 1st all the way to the end of October. For Southwest Missouri, though, generally, our hottest days of the year are that first 2 weeks of August. So we have a little bit of time before we get to that point. When we do get there, the average temperatures, average high temperatures during that time frame are 90 degrees. So once we start talking about that hottest period of the year, that first 2 weeks of August, the average daily high for that period is 90 degrees during that time frame. So that's really that peak of heating, so to speak, or the peak time frame where we see the warmest temperatures on average. As we go into some of the records that we've had across Southwest Missouri, kind of looking at Springfield, we can see that we have been pretty hot in the past with record high temperatures in June 1936, 101 degrees, 113 degrees on July 15th, 1954, which is actually the warmest temperature recorded at Springfield since records have been kept going back to 1888. For August, 108 degrees. You can also see that we have had some pretty cool temperatures as well. You know, as we look at the different months and getting temperatures down into the 40s during the summer months as well. So it's not out of the question we're not cool as well. Start looking at some of the wettest days on record. You know, there are days, of course, in summer where we don't get any rain, but others where we get more than we need. Just looking at some of those dates in June, July, and August, in excess of 4 or 5 inches on some occasions. Of course, we talk about summer heat again. You know, we start talking about consecutive warm days. You know, and 100 degrees is really kind of something that we don't necessarily see every summer. But in the past, we have had some stretches that have seen multiple days of 100 degrees or greater for high temperatures. That kind of peaked in 1980 in July when we had 13 days in a row where our high temperature broke 100 degrees. So hopefully we don't see that this year, or for my purposes ever. That's just too hot for me. But let's just kind of take a look at you know, some of the extremes that we have seen in summer for Springfield. You know, we start talking about those strings or stretches of days where we had 100-degree weather. Well, we can also have those stretches where we don't have any precipitation as well. We kind of looked at those extremes where we had 4 or 5 inches in a day. Well, we can also see stretches where we don't get rain for quite a few days in a row. Just taking a look at these graphs here, you can see the chances for consecutive rain-free days in June and July. And in general, you know, pretty good bet chance that during June and July, you could see 3 or more days that don't have any rain. Looking at June, you can see 55% chance or so during the month, at any time of the month, that you could actually see you know, rain-free periods. 65% in June, or in July, I mean, pardon me there. I don't have the graph for August, but it is very similar to July, where we have those periods where you can, you know, pretty good chance you're going to have a couple of days in a row that are dry. But you can also see as we go through those stretches of 8 or more days in July, 21% chance that could occur on any given June. Pardon me, getting my months mixed up here. And this is information this is looking back at consecutive days all the way back from 1888 through 2015. So you can see you get the potential there for some, you know, some long stretches without precipitation during June and July. As a matter of fact, you know, the longest stretches in June was 20 days, and that's actually occurred twice. Once in 1954 and also in 1953. And in July, we had probably one of our longest stretches in the summer that was 25 days long. That essentially was the entire month of July of 1999. I believe the rainfall that occurred on July 6th of 99 was a little bit less than half an inch. So I think that ended up being the total rainfall for the month in 1999. Not only do we look at those stretches of warm days and dry days and high temperatures during the summer, but we also see a change in the type of thunderstorm activity that we see during the summer as well. During the spring, a lot of our convection and thunderstorms are produced by frontal passages, the squall lines, You know, once we start getting into the summer, we really kind of transition into more convective storm complexes, something we call MCSs, or mesoscale convective systems. Those are develop during the late afternoon and evening out in the plains, and they will travel quite a long ways as those storms kind of congeal into that system. And they'll move across the area, the plains and Missouri and the Ozarks during late afternoon, overnight hours. And that's where we see the potential for some severe thunderstorms from those diurnally driven, heat-driven systems as they move across the area. And that season generally can begin as early as the end of May and goes through early July or so. You see those storm systems will come through overnight, most often for the Ozarks. And we can see quite a bit of rainfall with those, severe weather. You know, the other type of system or type of thunderstorms we also see during the summertime is pulsed thunderstorms. Essentially, pulsed thunderstorms are storms where we have very weak flow. It's kind of like watching a pot of water boil. You can see those bubbles popping up. Very similar in the summertime. They're heat driven. They develop over an area. They build up. They rain out, and they dissipate very rapidly. And that type of that pulse thunderstorm season is really late June through early September. So we're kind of getting into that period where we can see either of these types of thunderstorm systems. So when we start talking about the thunderstorms, you know, when we get into the summer months, you know, we start to have that transition in the type of severe weather we have as well. You know, traditionally, we start thinking of our severe weather season for the Ozarks as that you know, that springtime severe weather season. And in general, you could get the more dynamic severe weather during that time frame. But if you look at the chart here, you can see that we really peak in Storm Prediction Center outlooks during the month of June. And that actually continues all the way through July and August. So we do see that upward trend as we get into the month of June. It starts to drop off as we go through summer. But overall, we do see a pretty good amount of severe weather during the summer months. Again, primarily driven by those MCSs, those overnight storm complexes, and during the afternoons, with the heating of the day, with the pulse thunderstorms. The difference though in the types of outlooks that we get, generally by the time we get into the summer, we're seeing more of that marginal, slight, maybe enhanced risks of severe, where you can kind of see in May, April and May, a little bit more of that moderate and high risk primarily in May. So we don't see those really high risk, moderate risk days so much in the summer, except maybe June. And those moderate risks in June, generally speaking, are kind of earlier June, where we're on the tail end of our spring severe weather season. So what can we expect in those severe storms? Well, not only are we changing the type of storm that produces severe weather when we get into the summer, but what the storms produce as well. If you look at this, you can see that, you know, in March, March, April, May, that spring period, you can see that the peak in the tornadoes in May, that red bar, and then also in the green bar, the hail. You can see where that peaks in April and May. But notice the peak in the wind. We really peak with our wind reports during June and July. as far as the type of severe weather that we see during the summertime. And that continues to a little bit lesser extent during August. So we're transitioning that type of severe weather as we get into the summer months. And part of that is that change in the season. You get a little bit less shear available for the storms to access. And with the winds, you can get those with the overnight thunderstorm complexes, the MCSs, as they're moving through an area. With the wind and hail for the pulse thunderstorm type of severe weather we get, as those storms build up, they've got a lot of energy going up, but generally what goes up must come down. And while you can get some pretty big hail in those pulse type thunderstorms, as those storms collapse, that air rushing down towards the ground can also cause wind damage as well. So those are some of the type of severe weather events that we can see during the summer months as we transition out of spring. But it's definitely not a period where we don't get severe weather or we get less. We just transition to a different type of severe weather or different different outcome from the severe storms. So that's kind of a look at some of our normal summertime climatology, what we can kind of expect during the summer months. But when we start talking about the 30-year normals, we're talking about temperatures, precipitation over our 30 years. And when we talk about 30-year normals, that's actually a 30-year climatological period that is averaged, updated every 10 years. So, for example, that our next set of normals will come out in 2031, which will lose the 1990s period, but will add the 2020s, so to speak, up through 2030. And every 10 years, we update those normals. The first normals in the United States were actually the 1901 to 1930s normals that were commissioned in 1931 by at the time, the Weather Bureau. So we've actually been developing these normals and producing them every 10 years since the early 1930s. So what are our new normals for the 91 to 2020 period? Well, as you can see here, the new normals for the area, including Springfield, Joplin, and Vichy-Rolla area. You can see, for June, July, and August, anywhere from 3 to 5.5 inches of rain, depending on where you're located for the month, is the new normal or the new average, however you want to say it. The average temperatures, average high temperatures, average low temperatures, and then the average monthly temperature are anywhere in the 80s to around 90 degrees, depending on where you're out in the Ozarks. Average overnight lows in the middle, low to middle 60s, upper 60s for some locations in July. But overall, the average monthly temperatures are going to be in the mid 70s to upper 70s for the most part. This is great information to have, but what's changed? Just looking at the Springfield normals, you can kind of take a look here with red being warmer for temperatures. Well, essentially every month, every period is warmer than the previous normals period that ran from 1981 to 2010. In some cases, that increase was as little as 1/10 of a degree. In some months, it was as much as 1.5 to almost 2 degrees. So we can definitely see that things are warmer than the previous set of normals. On the bottom row, you can also see the precipitation. Well, some months have become drier than the previous set of normals, but we also have several months and our annual rainfall that is actually increased. January, April, May, July, and August all have increased the average monthly precipitation with the new set of normals. Well, let's kind of put that in perspective, though. Yes, our new set of normals is warmer across the board. But what we see here, and these are on the left-hand side, it's the normal monthly high temperatures, and on the right-hand side is the normal monthly low temperatures. Well, if you kind of look at June, we can see that generally from the normals period, and what we're looking at here is the 30-year normals updated every 10 years. So the far left, the red bar, is the 21 to 1950 normals period. Then we go all the way over to the black bar on the right-hand side, which is this new normals period from 1991 to 2020. So we're just looking at the normals and the change in that normal period. And you can see that there's that trend in June, for warmer weather. Now, if you were to drop off that 21 to 50 period and look, there's really not a whole lot of change, maybe a few tenths of a degrees in June. And really, if you kind of look at July, the new normals that we're going to be using here over the next 10 years for high temperatures is actually cooler than some of the previous climate normals periods we've had. Same thing with August. So as far as the average highs for the 30-year normals period for summer, there's really not a whole lot of change from the long-term climatological periods that we've been looking at. But when you start looking at the normal monthly low temperatures, that average low temperature during the month, there's definitely a trend to warmer low temperatures across the area. One thing you'll notice, though, is this big dip in the middle in June, July, and August. If anybody remembers the 60s and the 70s, which are included in these two, the tan and the blue, 1951 to 1980 and 1961 to 1990 periods, those were pretty cold. The 70s especially were a relatively cold decade on the whole, so that did skew some of that data. But if you do look at just kind of a trend line, you can kind of see that warming trend in the monthly lows temperatures. Well, what about the average temperatures as a whole, which is kind of what we were looking at previously? There is a slight warming overall, but this is more effect of the warmer average lows than increasing high temperatures. So while our average monthly temperatures are warmer, again, this is more an effect of those warmer overnight low temperatures. And this could potentially have an impact if we continue to see this on a lot of different things. The health sector, when we start talking about heat, heat waves and things like that. One of the things that we use to determine heat is when the overnight temperatures don't fall below 70 degrees for a long period of time. That in addition to heat indices and things like that. By not getting colder at night, it has an impact on how things can reset. That also affects agriculture as well. A lot of plants need that reset period overnight. That's one thing that we're seeing with the changes in that the climatological normal period that we are now going to be using for the next 10 years is that warming trend, but primarily that effect from the warmer overnight lows. As far as precipitation, well, again, looking at that long-term trend, you start looking at the 1921 to 1950 trend, it was pretty wet in June. Over 5.5 inches was the average monthly precipitation during that time frame. Now we're below 4.5. So you can definitely see that downward trend in monthly average precipitation during the month of June. However, when we start looking at July and August, if you kind of fit that trend line, you know, it's a little bit wetter in July. August, about the same. If you were to take off that 1921 and 1950 or average these out, it would be fairly similar to what we've seen, especially at least over the last 4 climatological periods. So, you know, that's something to keep in mind as we go through the next 10 years. Is maybe that trend towards you know, maybe a little bit drier Junes, maybe a little bit wetter Julys, and August, you know, as it stands now, pretty similar to what we've seen over the last 3 to 4 climatological periods there. So what about the long range forecast? We've looked at what we can normally expect, what the new normals are. You know, when we start talking about the longer term forecast, of course, one of the main global circulations that can have an impact on that longer term forecast, of course, is ENSO. It's that El Nino Southern Oscillation. It's that area of the Pacific that determines whether or not we're in El Nino or La Nina or something in between, which is called neutral. Now you'll notice on the right-hand side here these weather patterns, which are fairly standard, and you may be very familiar with them or you may not. But one of the things I want to caution you about on these is what they're showing here is the winter patterns. This is what we would expect the potential impacts would be during winter. Well, when we start talking about a lot of your teleconnections, ENSO included, they tend to have less skill in longer range forecasting during the summer. Part of that may be because patterns can become a little more stagnant. You can have periods where you have an upper level ridge or high pressure that sits over an area for a long period of time. The Bermuda High, which is kind of a well-known feature that develops off the East Coast, and it can impact areas as far west as the Rockies sometimes, and it will sit there for a long time, sometimes a month or so, can have an impact. So just keep in mind that when we start talking about some of the El Nino, the ENSO impacts, that the skill in those is a little less than they are in the wintertime. With that said, the forecast for ENSO from now through summer and actually into the fall is for ENSO neutral conditions to continue. We just, as a matter of fact, had La Nina end last month, and ENSO neutral conditions are expected to continue this month and into the fall. So what can it have? What kind of impacts can that have? Well, we start looking at the historical ENSO probabilities for the Ozarks, and this is for actual Springfield. We start looking at some of those historical probabilities, and when we start looking at the average temperature for summer during ENSO neutral conditions, which is what we're expecting this summer, there have been some historical probabilities that do lean towards cooler or below normal average temperatures during that summer period based off those historical probabilities. That's not to mean that we can't see warmer than normal temperatures or average temperatures during that 3-month period, but there is some statistical significance that would indicate that ENSO neutral summers as a whole, that whole 3-month period, has been cooler than normal in the past. Well, again, that's the average monthly temperature as a whole. If we start looking at average highs and average low for those time frames, well, there's really not a whole lot of significant differences when we start looking at neutral conditions for average high temperature and average low temperature during that period. You can kind of see that the counts, when we start looking at these are the percent of the number of years where we've seen ENSO neutral conditions, that the counts are fairly evenly distributed during those years when we start talking about the average highs and the average lows. There's a little bit of a increased chance or count of years for that cooler than normal conditions, which may go along with the average that we just saw. When we start talking about precipitation for that same time frame, really not a whole lot of statistical significance. Again, nothing really stands out from that. But just looking at the counts of years, again, the percentage of years around normal, that's that gray bar in the middle, around normal conditions for neutral ENSO conditions is what we would expect for the summer months. Just looking at some of the past years where we transitioned out of La Nina at the end of spring and into neutral to start the summer. Looking back at similar years that had that same pattern. 1976, 1989, 96, 2008, 2012, and 2018 were all had that same type of pattern where we transitioned out of La Nina and into neutral for the summer. And what we're looking at here is that average monthly temperatures again. Well, in four of the 6 years, we can see that we were actually cooler. What we're seeing here in 1976 during June, July, and August, it was actually cooler than the corresponding 30-year normals for that period. The same thing for 89, 96, and maybe to a lesser extent 2008. But then we get into 2012 and 2018, quite a bit warmer for the most part during those time frames. Started thinking about that. Why did that happen? Well, one reason is we're in the middle of a drought in 2012 and in 2018. We were not in those other 4 years. Generally, that dry weather, that dry conditions can lead to increased temperatures. And that would be something that we may have another webinar on in the future. Looking at rainfall, well, not a whole lot there as far as anything, any type of pattern you can see. Not like the temperature that we just looked at, which kind of fit a little bit with that neutral expectation from the historical perspective that suggested cooler average monthly temperatures that we saw in 76, 89, 96, and 2008. So we're just kind of all over the map when it comes to the precipitation. So what is this outlook for the summer? You know, and the Climate Prediction Center does a pretty good job when it comes to doing their forecasts. But again, and some of you may have already seen this, when we start talking about the Climate Prediction Center's forecasts, it's all about the chances and how they differentiate that. So when we start looking at how they're building their forecast, they break it up into 3 parts. So think of it as a pie with 3 different flavors baked into it. So if you get a forecast of EC, or equal chances, that means that there's just not a whole lot of skill in the models. So you'll get probabilities of above, below, or near normal conditions with equal chances. Well, if you shift those chances, and there is skill, in this case, you'd have a much higher chance to get warmer than normal conditions, but you can still, even though you get that forecast of warmer than normal, you can still get below normal conditions. You just have a smaller chance to have that happen based on the forecast. So when we start looking at the forecast for the rest of June, this is the current forecast from the Climate Prediction Center for the remainder of June. And you'll see from most of Missouri, when it comes to temperatures, except for maybe that very small far southwest corner, we're in that EC area. There's a slight lean towards cooler than normal for the far southwest corners of Missouri, which is you know, the southwest corner of the Ozarks here. But there is also a slight increase in the chance for wetter than normal conditions. And if you kind of look at where they've got this drawn, it's almost right along I-44 and south. So you know, that's what we'll potentially have in our forecast here for the remainder of the month from the Climate Prediction Center. Now, as we go through summer, again, you know, we start looking at that forecast here of EC, equal chances. There again, we start talking about not a lot of skill for this area from some of the models because of the lack of skill for a lot of those global circulations in the models. So you know, really near normal or equal chances of one of the, you know, above, below, or near normal to occur for this summer based on the current forecasts. With that said, you know, it has been fairly wet through the beginning of this year. Similar to last year, we've had a pretty good wet start to the year, and because of this, for Southwest Missouri, we don't have any drought currently. Now, if you look at the state of Missouri, there's a few areas of D0 or abnormally dry weather up in the far northeast part of the state, and I think over kind of near St. Louis as well, but they're very small areas. And the good part is that as far as the drought outlook for the remainder of summer, we're really not expecting any drought to develop. One of the things that may help us with that forecast for no drought to develop is the current soil moisture that we have across the area. These maps are from the USDA, and they measure topsoil moisture, or that top 6 inches or so of the soil. On the left-hand side here, we can see for the state of Missouri, it's blue, so it's currently sitting at wetter than normal. But the interesting thing is to see how much wetter. And what we're doing here is they're measuring agriculturally. They when they measure the topsoil moisture, they measure it in short or very short, adequate, or excellent. And right now, as it stands, only about 2% of the state of Missouri is in that short or very short, which would be drought-like conditions or very dry soil. If you look at the 5-year running mean at this time of the year, that normally sits at about 11%. So we're much better off than the 5-year average. On the 10-year running average, which is on the right-hand side, we're even better off. So our soil moisture right now, because of the rains we had in the spring, is doing pretty good, and that will potentially help us as we go through the remainder of the summer. That will also likely help keep temperatures in check a little bit, because a lot of the temperature, the heat as we go through the summer months would have to dry out the soils before we could get any really warm temperatures. So that will actually help us from getting too hot as we go through the summer potentially. But other than that, that's really what we're looking at right now. Here's a couple websites and resources that I used and that you can get some more information of or for the summer forecast. Some really good information here in all of these locations from the CPC and International Research Institute, Climate Prediction Center's website, climate.gov, and the Weather Prediction Center as well. A lot of additional great information and resources there. But at this point, not only do we have this presentation, but we also do have another one coming up here next month in July, Festivals and Lightning, how to incorporate the National Weather Service lightning detection notifications in your decision making. So we will continue doing the webinars as we go through the summer, and hopefully we can get you all to attend that one as well. If you have any questions, I'd be happy to answer them if I didn't get to them while I was going through the presentation. But if you have any additional questions, there's multiple ways for you to get hold of us and ask. Thank you very much for spending your afternoon with me, and hopefully it was informative, and be happy to take any questions.
Okay, thank you, Gene. We have not had any questions come in, so we will hang tight here for a couple of minutes. I did put in that link for the festivals and lightning, how to incorporate NWS, National Weather Service lightning DSS notifications in the chat portion. So if you would like to register for that, that particular webinar is pretty important, especially when it comes to thunderstorms being a great distance away from the fair or the festival, or the search for the missing child, or any other event that you might have in your jurisdiction. So wanted to make sure everybody had access to that particular webinar as well. So going back to the climatology and look ahead that Gene provided. Any last questions for Gene? And again, if you're new to GoToWebinar, just please go to that question box in your GUI on the right-hand side of your screen, and you can ask the question that way. Stephen Krieger did ask if the websites can be provided via email, and I'd be more than happy to get something out, Gene. I think that's something we can do.
I definitely believe we can, yes.
Okay. Gene, I'll put you on the spot. What do you anticipate from a tropical perspective, and what's the normal effect here in the Ozarks from a typical tropical season?
Well, in a typical tropical season, we can expect to see a handful of tropical storms move through the Gulf and impact the Gulf states. For the most part, you know, we don't see a whole lot of tropical storms make it this far north into the Ozarks. However, we have had some in the past. In general, if a tropical storm can stay together and make it into the Ozarks, you know, they can be pretty good rainfall producers. You know, I believe it was Gustav a few years ago that moved into the area, and I think that during the time frame it moved across the Ozarks, produced 4 to 7 inches of rain in some locations during the summer months. So it is possible that we do see tropical systems get into the Ozarks. Doesn't happen every year, but when they do, they can produce some pretty heavy rainfall and also some severe weather, you know, gusty winds and things like that.
Okay, thank you for that. We did have a question come in from Lewis. Lewis, I don't know if you saw my response. You had asked about how much rain for the year. I assume that you're asking about rainfall year to date, as opposed to rainfall associated with the new 30-year normal. If you could respond via the chat box, I appreciate that. Gene, do you know off the top of your head where we're at year to date?
I probably should have written this down, but I do not know where we're at right now. However, I could find that out very quickly. So give me, I can look that up right now. This will see here. Apologize for making you listen to dead air here for a second. Let's see. Oh, that is not good.
And Gene, while you do that, I just want to say thank you to Patty for her thoughts, and Wayne Nelson, thank you for your kind words as well.
Okay. Well, as it stands right now, we currently have, we're sitting at 28.44 inches for 2021 to date. This is actually a little bit above where we should be for this year. So we are running above normal by about 6 inches above normal or so. Now, you know, the wettest year that we have on record actually was, let's see here. Uh, 2008, believe it or not. At this same date in 2008, we had 36.70 inches of rain already. So, you know, we're not near there yet. We're sitting at 28.44, and like I say, normal through today, based on the new climate normals, is generally 20.85. So we're actually just shy of 8 inches above normal for the year, looking at this.
And Gene, if I'm not mistaken, we were about 35 inches year to date last year, so pretty close to that all-time record that you just mentioned. And
Yes.
within a couple of weeks, it seemed like we had gone from so high above normal to the start of a drought.
Mm-hmm. Yeah, and I mean that could happen at any time. We you know, you kind of look back and anecdotally over the last several years, it has seemed that our springs have been fairly wet, and then once we start to get into the summer months, you know, we see drier conditions occur, and part of the reason is going back to, like I'd mentioned, those stagnant patterns. If we develop a stagnant pattern, it can very well happen, but that doesn't happen every summer. You know, we saw, kind of looking back at some of the years in the past where we had very wet June or July or August. So it's not necessary that you know, we're going to, you know, develop another drought this summer.
And speaking of drought as well as rainfall, I'm reminded during the Great Flood of 1993, the crops in the northwest part of Missouri all flooded, and the crops in the southeast part of the state all died because of drought.
Mm-hmm. That's correct. So, you know, when we start talking about summer weather patterns, it can, in very short distances, you can have feast or famine, so to speak. You know, if you think about the pulse thunderstorm season, you know, you could have storms develop and sit over Springfield and get multiple inches of rainfall, but Ozark or Republic could not get a drop. Same thing can happen, you know, with portions of the state as well, where, you know, MCSs may develop and move over the northwestern part of the state, as Steve mentioned back in '93, where you had multiple nights in a row with heavy rainfall, but by the time they get down to the southeast part of the state, they've dissipated and gone. So, you know, summer can be very unpredictable as far as how the weather ultimately develops.
Okay, all right. So with that, I think we will end the webinar. Gene, I do thank you very, very much, and for everybody who attended, I thank you as well. Again, we had a good cross section. We had some emergency managers, some amateur radio, Kansas DOT, several different groups. So Gene, I do thank you very much. And with that said, everybody have a good afternoon.
Thank you very much.